Hey, hi, welcome to the class. So, this session is about GATE 2020 ECE paper, and this is about signals and systems. So, in this lecture, I'm going to discuss about the, the questions, GATE questions, ECE GATE questions of signals and systems. Right, there are around six to seven questions in signals and systems. Let us solve them. Right. So let us solve this question. So they are saying input-output relation is given as y of t equal to maximum of modulus of x of k, where k runs from minus infinity to n, the present time. So the meaning of this is among all the values of x of k till the present value, whatever is the present value, till the present value, whatever is the maximum sample value, that will be the output. So for example, if I'm saying y of 4, the meaning of it is maximum of k running from minus infinity to 4 modulus of x of k, which means among it is nothing but maximum of x of 4, x of 3, x of 2, and so on till x of minus infinity. Among all these values till the present sample, whatever is the whatever is the magnitude of the maximum sample value, that is the output. So that is what is the meaning of this system. So they're asking us the unit impulse response of the system. They're asking us to find the output of unit impulse. So for example, let's say the input x of n is equal to del of n. So if the input is del of n, so we can plot this input. You can plot it like this. It is 1 at 0, n equal to 0, and it is 0 at other places as a function of n. This is how x of n equal to del of n looks like. Now let us find the output. Once you pass this signal through the system, through the system with this function, the output y of n is equal to for n equal to minus 1, for when n equal to minus 1, from minus infinity to minus 1, whatever is the maximum sample value, that is the value of output at minus 1. So let me say this is 0 seconds. At minus 1 till minus 1, what is the maximum sample value? No sample value, all the samples are 0. So the sample value at minus 1 is 0 only. The sample value at minus 2 till minus 2, what is the maximum magnitude of the sample? 0 again. So till minus 1, everything is 0. And at 0, when n equal to 0, y of 0 equal to minus infinity less than or equal to k less than or equal to 0 mod x of k, which means among x of 0, x of minus 1, x of 2, and so on, x of minus 2 and so on, what is the maximum magnitude? So at 0, when n equal to 0, the maximum magnitude possible till 0 is 1. So at 0 it is 1. Next, at n equal to 1, when n equal to 1 till 1, what is the maximum sample value? The maximum sample value is at location 0, which is equal to 1 again. And at n equal to 2 also, till 2 seconds, what is the maximum magnitude of the input sample? It is again 1, and so on. So this function, if you observe, it looks like u of n. So when the input is unit impulse function, output is step function. So the unit impulse response of the system is unit step signal. Fine. So this is the answer for the first question. Let us see the next one. So they have given us the difference equation satisfying the input and output of a system, and they are asking us the pole zero plot of that system. If you want to understand the pole zero plot, so you should get h of z. If you want to understand the pole zero plot, you should get h of z. H of z is what is required for us. If you can find h of z, you can understand what are the location of poles and zeros. So if you want h of z, you should find what is h of n. If you can find h of n, you can find h of z, and you can say the pole zero locations. Right. Observe this function. So we can write this as output y of n can be written as x of n convolution with h of n, which also can be expanded as h of k into x of n minus k, where k runs from minus infinity to plus infinity. Or we can also write it as sigma x of k into h of n minus k. Both are correct. So, but if you look at this one, this looks close to this one. So let us understand this function, whatever they have given you, in terms of this function. So let us understand it as h of k. Yeah, if you can look at, so definitely we can observe this function. This function and this function are exactly same, but based on h of k, the limits have changed. Okay, so from this we can understand that h of k should be equal to minus 1 whole to the power of k, because in place of h of k we are having minus 1 whole power k, but the basically limits are from minus infinity to plus infinity, but here the limits have changed from 0 to infinity because h of k exists only from 0 to 3. Because h of k function is like this, you can substitute this function here, then you are going to get exactly this function. So by observing, you can understand what is h of k, right? So, and it is equal to 0 elsewhere. So h of k or h of n is equal to, for k equal to 0 it is plus 1, for k equal to 1 it is minus 1, for k equal to 2 it is plus 1, for k equal to 3 it is again minus 1. So this is what is h of k. So or h of n or h of k both are same. So we got h of n. H of n is equal to 1 minus 1, 1 minus 1. Arrow mark at 0. Now we can find h of z. H of z is equal to, you can find the z transform of this. It is 1 minus z to the power of minus 1 plus z to the power of minus 2 plus, sorry, minus z to the power of minus 3. From, you can find the z transform of this. It's very easy z transform. So this is equal to 1 minus z to the power of minus 1 plus z to the power of minus 2 into 1 minus z to the power of minus 1. So which is equal to 1 minus z to the power of minus 1 into 1 plus z to the power of minus 2. Or we can also rewrite it as z minus 1 into z square plus 1 divided by z cube. We can write like this. Now tell me, what are the zeros? Zeros implies 0, the h of z function or z transform or transfer function happens to be 0 when z equal to 1, or when z square plus 1 equal to 0. Z square plus 1 happens to be 0 when z equal to plus or minus j. Substitute plus or minus j here, or z square plus 1 should become 0, which implies z square should be equal to minus 1, which implies z is equal to plus or minus j. So the zeros are 1 plus j and minus j. Next, poles. How about the poles? Poles are at 0 only, 0 comma 0 comma 0. Third order pole at z equal to 0. Right. So let us check the options. They are asking us about pole 0 plot. 3 poles at 0. 3 poles at 0. See this one? The third order, fourth order pole. No, this is cancelled because the only third order pole at z equal to 0. Third order pole, third order pole, third order pole. Among these three options, poles are correct only. How about zeros? 0 locations are at 1 and plus or minus j. 0 locations are at 1 plus, here 0 location is not there at 1, so this is cancelled. So 0 location is there at 1 plus j and minus j. 1 plus j minus j. This one, option 3, satisfies the pole 0 locations, pole 0 plot. So this is not correct because the 0 is at minus 1, but the 0 should be at plus 1. Yes. Next, let us talk about this one. So before talking about this one, let me give you some basic here. If you're talking about an LTA system, generally, we should be knowing the concept of eigenfunctions. If at all, if you apply an input j omega naught into t as input to the LTA system, generally this function, exponential functions or complex sinusoidal signals, these signals are eigenfunctions of LTA systems, which means the output of, when the input is given as input is eigenfunction of the system, the output will be same output but multiplied with some constant. And that constant is equal to h of omega naught into e power j omega naught into t. Similarly, if it is e power at, output is some constant times e power at. The exponential function is also an eigenfunction of LTA system. So that's why whenever you give eigenfunction as input to LTA system, the output also will be exactly same but multiplied with some constant. That constant may be a complex constant. And this k is nothing but h of s equal to e into e power j omega naught. The meaning of this is, in the Fourier transform, substitute omega equal to omega naught. Substitute omega equal to omega naught. And if it is exponential function, substitute in the Laplace transform s equal to a, that will give you the constant. This constant will be given by Laplace transform substituted with s equal to a. Similarly, if it is cos omega naught t, generally, if cos omega naught t is the input or sin omega naught t is the input, so cos omega naught t and sin omega naught t is also can be written, cos omega naught t can be written as combination of e power j omega naught t and e power minus j omega naught t. So the output will be again some constant times cos k omega naught t, which is equal to h of omega equal to omega naught into cos omega naught t. So similarly for sine function also same answer. So if the input is sine function, then output is same sine function multiplied with some constant, and that constant is given as Fourier transform of the system substituted with omega equal to omega naught. Right. Now let us do the problem. So g of s is given 1 by s plus 1 into s plus a. Fine. So the input is 5 cos 3t. 5 cos 3t is given as input to the LTA system. The output will be constant times 5 cos 3t, and this constant k is given as h of omega equal to omega naught. Right. So, and what is that omega naught? Here you can observe that the frequency, angular frequency here is omega naught equal to 3. So which means you can just substitute omega equal to 3 here, which is equal to. So first of all, you should know the Fourier transform, then you can substitute omega equal to 3, and then you can get the constant k. Right. So to get Fourier transform from the Laplace transform, you can just substitute s equal to j omega. So which is 1 by s plus 1 into s plus, sorry, replace s with j omega. If you want to get Fourier transform from Laplace transform, replace s with j omega. Right. So now you have to find h, means generally h of omega is taken as transfer function, Fourier transform of the system. But here, instead of h of s, they have taken the notation as g of s. That's fine. Basically, we take the notation as h of s and h of omega. Here they have taken the notation as g of omega and g of s. No problem. So g of j3 or g of omega equal to 3 implies 1 by j3 plus 1 into j3 plus a. Okay. So this can be written as this constant we can find as h of omega equal to 3 is 1 by, okay, let me do it here itself. It is 1 by, so this is a, we can write this as 1 root of 1 plus 3 square plus 1 square at an angle of tan inverse of 3 by 1 into root of 3 square plus a square at an angle of tan inverse of 3 by a. Right. So this is equal to angle of minus tan inverse of 3 minus tan inverse of 3 by a into magnitude is 1 by root of 10, this is 10, root 10 into the magnitude of this is root of 3 square plus a square. So this is what is the k value. Now it is multiplied with 5 and they are saying the output is 1 by root 10. The output is 1 by root 10. So 5k should be equal to 1 by root 10. So magnitude of 5k should be equal to 1 by root 10. So you can understand that 5k should be equal to 1 by root 10. In the magnitude of k here, you can find that h of omega equal to 3, we have found just now, which is 5 times 1 by root 10 into 1 by root of 3 square plus a square is equal to 1 by root 10. So root 10 cancelled. So 5 is equal to root of 3 square plus a square. From this we can find that a is equal to a square is equal to 4 square and a equal to 4. Or actually, basically speaking, a should be equal to plus or minus 4. Is a plus 4 or minus 4? Since options are not there, we have to write the perfect answer. So actually a can be plus 4 or minus 4. Whether it is plus 4 or minus 4, we have to decide based on the phase part. If you observe, you can see the phase part as minus 1.892, minus 1.892. So let us understand this one. Right, here let us understand it. So the output is 1 by, 1 second. Actually, we got the answer as a can be plus 4 or minus 4. We have to choose whether it is plus 4 or minus 4. So basically, the output, we got it as 1 by root 10 into cos of 3t minus 1.892, something like this. So the phase part here is minus 1.892. And the phase part that we got is minus tan inverse of 3 minus tan inverse of 3 by 8. Okay, so a should be either positive or negative, we have to understand. So tan inverse of 3 is positive only, and tan inverse of 3 is basically just more than, so minus 1.892. We have to just guess this. We don't need to exactly find the value here. We just need to guess whether, we know either a can be either plus 4 or minus 4, right? We just need to guess one of these two options, right? So let's assume if a is a negative. Let's assume if a is a negative, what happens is, if this is negative, then this angle is also negative. Negative into negative is positive, so this becomes positive. So this angle is something which is like little greater than, this angle is greater than 45. So this total thing is greater than, this total thing is around minus 50 or minus 55. And if this is plus, then this becomes a smaller negative angle, but this is a bigger negative angle. So this is something like, this angle is little greater than pi by 2. So basically pi by 2 is 3.14 divided by 2, which is 1.57. So this angle is, this angle, apart from minus, this angle is little greater than pi by 2. So if a is a negative, this does not, both sides will not be equal. If a is positive, then only this angle and this angle gets added up and it becomes a bigger negative angle. So that's why a should be positive. So basically a can be either plus 4 or minus 4. Only by using the magnitude, we can only decide whether it is plus 4 or minus 4. We cannot exactly say whether it is plus 4 from the magnitude itself. So we have to compare the phase parts, this minus 1.892 and this part, and we can understand that a should be plus 4. Right. So let us come to the next question. So this question can be done in 2 or 3 ways, multiple ways. I would be doing it in using DTFS concept, DTFS, Discrete Fourier Series concept, if you can use. That would be giving the answer in a faster manner. We'll do it in using DFT procedure as well. So let us do it using DTFT concept. So x of t is equal to cos of 200 pi into t, replace it with n by 400 because they are sampling, and this is equal to cos of pi by 2n. X of n, yeah, x of n is cos of pi by 2n, which we can write it as e power j pi by 2n plus e power minus j pi by 2n divided by 2. So this is what is x of n, right? You can observe that DTFT is taken for 8 samples, so which means capital N equal to 8. And this implies fundamental frequency is 2 pi divided by n, 2 pi divided by number of samples, which is equal to 2 pi divided by 8. Right. Now, so fundamental frequency is 2 pi by 8, or which is also equal to pi by 4. So fundamental frequency is pi by 4. Second harmonic 2 omega naught is pi by 2. Third harmonic is 3 pi by 4, and so on. And if you observe this, what harmonics are there in this signal x of n? Pi by 2 is present. Pi by 2 means it's the second harmonic. Second harmonic is present means C2, Fourier series coefficient C2 will be equal to 1 by 2, and this corresponds to C minus 2. C minus 2 is equal to 1 by 2 again. So C2 and C minus 2 are half and half. So now tell me, if C2 is half, we know that Fourier series coefficient, DTFS, discrete time Fourier series coefficients, are periodic. Ck is equal to Ck plus n. Right? Here, C2 is same as C2 plus, what is the n value? Capital N value is 8. And which is equal to C2 plus 8 is nothing but C10. Right? Similarly, C minus 2 is equal to C minus 2 plus 8 is equal to C6. So which is equal to, what is C6? C6 also is equal to C minus 2, which is half. C2 is half and C minus 2, C6 are also half, right? And we know, if you have listened to my class, I would have started with DTFS, discrete time Fourier series, and then I would have linked it with DFT. The relation between DFT and discrete time Fourier series is very simple. X of k is equal to capital N times Ck. Discrete time Fourier series coefficients are Ck. If you multiply them with the capital N value, number of samples, you get capital X of k, which is nothing but DFT. This is DFT. This is discrete time Fourier series, DTFS Fourier series coefficients. Right? If that is the relation, so now tell me, so if C2 is half and C minus 2 and C6 are half, so tell me other values. C0, other coefficients are 0 because the other frequencies are not present here. C0, C1, C3, C4, C5, C7 are all zeros. Only C2 and C6 are non-zero. Now coming to x of k equal to capital N times Ck. Ck means, what is Ck? C0, C1, C2 and so on. And so on, C7. So let us write capital N value in this case is 8 multiplied with C0 is 0, C1 is 0, C2 is half, C3 is 0, C4 is 0, C5 is 0, C6 is half, and C7 is 0. Now if you multiply with 8, this becomes 0, 0, 4, 0, 0, 0, 4, 0. So this is the answer. Yeah, perfect. So x of 0, x of 1, x of 2 is non-zero, x of 3, x of 4, x of 5, x of 6. X of 2 and x of 6 are non-zero. So this is the perfect answer. This is how you can do it using discrete time Fourier series. If you have understood the concept, you will not take this much time. Since I'm explaining in detail, it is taking so much time. Otherwise, it would have been a very simple question. Right? This is one way of doing it. So what is the other way of doing it? So let me give you the other way of doing it. Right. So let me do it here. So let me give you some property here. After that property, you can easily guess the answer. A, B, C, D. If you know the DFT of A, B, C, D as P, Q, R, S, then if this is, let me say it is x of n and this is x of k. Now if A, B, C, D is repeated, now it becomes an 8-point DFT. Now the DFT, using the property, I am telling you a property using which you can find the DFT very easily if you face this kind of situation. If you know the DFT of a particular sequence, and that sequence is repeated, then DFT will be, it is very simple. It is nothing but how many times it is repeated, that number you should multiply. 2 times it is repeated, so I am multiplying with 2, and x of k is scaled. So it is 2 times x of k by 2. Scaled or interpolated, you can say 2 times. What is x of k by 2? So it is p0, q0, r0, s0. This is how it will be. Similarly, if ABCD is repeated thrice, then it would have been 3 times x of k by 3. So like this, you can extend it for any number of repetitions. But whenever how many times it is repeated in time domain, that number is multiplied as scaling factor. Similarly, let us discuss the opposite of it. So if you do x of n by 2, if you do x of n by 2, which means if you do interpolation, zero interpolation in time domain, a0, b0, c0, d0, then what happens in DFT in the frequency domain is just the opposite. If you do repetition in time domain, interpolation is happening in frequency domain. Okay. Similarly, if you do interpolation in time domain, repetition will happen in frequency domain. So it will be PQRS, PQRS. There is no multiplication factor when you do scaling in time domain. Okay. So if you ever get a confusion whether there is a scaling factor or not, where if scaling in time domain, will there be a multiplication factor, or if it is scaling in frequency domain, will there be a multiplication factor? If there is a confusion, just use a simple basic. So summation of all the samples will give you the first value of DFT, right? First value of DFT. So if the same samples are repeated twice, what happens? Summation will become twice, which means the first sample will be twice of the previous case, which means when it is repeated in time domain, then only there will be a multiplication factor or scale multiplication factor for amplitude in frequency domain, only in the time domain repetition case. Okay. Here, since you are adding zeros, addition of all these samples will remain the same as the previous case. Okay, that's why there is no multiplication factor here. If at all, if you forget where in what case, this case or this case, in one of these two cases, there should be multiplication with the constant. So in which case, if you are confused, just use this basic. Sum of all the samples should result in the first value of DFT, x of capital X of 0. Right? Use just that basic, you'll get the answer. Now, having understood this, let us try to answer the question. If you observe, what they are asking us is, they have given us x of k, x of n. If you write x of n, if you write for different values of n, for n equal to 0, it is cos 0, which is 1. For n equal to 1, it is cos pi by 2, which is 0. For n equal to 2, it is cos pi, which is minus 1. For n equal to 3, it is 0 again. And again, 1, 0, minus 1, 0. This is what they are talking about. Okay, fine. If this is what they are talking about, let us use the property 1, 0, minus 1, 0, 1, 0, minus 1, 0. Tell me, what is the DFT of 1 and minus 1? DFT of 1 minus 1 is, DFT of 1 minus 1 is, addition of these two samples will result in 0, and subtraction of these two will result in 2. DFT of 1 minus 1 is 0, 0 and 2. Now let us use one of these properties. So what I'll do is, I'll repeat it. So I'm repeating in time domain. So what happens in frequency domain? It will be multiplied with 2. So 2 multiplied with frequency scaling or frequency interpolation. So insert zeros in between. So 0, 0, 2, 0. So it will become 0, 0, 4, 0. Now if you do interpolation in time domain, 1, 0, minus 1, 0, 1, 0, minus 1, 0. So if you do interpolation in time domain, what happens in frequency domain? It's just repetition without any scaling factor. So the DFT of this is 0, 0, 4, 0, 0, 0, 4, 0. So this is the DFT, capital X of 0, capital X of 1, capital X of 2, capital X of 3, capital X of 4, capital X of 5, capital X of 6. So what they are asking us, they are not even asking us the exact values, they are asking us what locations it is non-zero. For k equal to 3, for k equal to 2, and for k equal to 6, it is non-zero. So I have given you two procedures to solve this problem. You can use one of those two procedures. Right. So we are done with this question. So let us do the next one. So here they are asking us to find mod x of omega whole square. Immediately you should get the idea that they are talking about energy theorem. So energy theorem, you should get the idea. Whenever a signal is squared and integrated, it means that they are talking about energy. So they are given the time signal, but they are asking us to find integration of mod x of omega whole square d omega. This is what they are asking. So now let us get the property. What is that property? 1 by 2 per times integration of mod x of omega whole square d omega is same as energy in time domain, which is integration of mod x of t whole square dt. limits from minus infinity to plus infinity. Since they have given time signal, you can find this and you can find the value that they are asking. So whatever value they are asking is integration from minus infinity to plus infinity mod x of omega whole square d omega is same as just send the 2 pi onto the other side. It is 2 pi times integration from minus infinity to plus infinity mod x of t whole square dt. And if you observe this signal is symmetric. Whatever is the signal from minus 1 to plus 1, same is the signal from 1 to 3. So since it is symmetric with respect to 1, so if you find the energy from 1 to 3, the energy will be same from minus 1 to plus 1 also, because same signal from minus 1 to plus 1, same amplitudes. So energy means it's nothing but square the amplitude and find the area. So if you find the energy from minus 1 to plus 1, same is the energy from 1 to 3. So we can save some time here if you use that basic. So it is equal to, so basically the meaning is from minus 1 to 3 mod x of t whole square. Because the signal is having symmetry with respect to 1, you can write it as it is 2 times of energy from 1 to 3. Integration of mod x of t whole square dt. Or you can also write it as integration from minus 1 to plus 1 also. Minus 1 to plus 1 also, no problem. Area from minus 1 to 1 or area from 1 to 3, both are same. Or energy from minus 1 to 1 or 1 to 3, both are same. Right. So to find this, it is 4 times pi into, yeah. So to find this, you have to write the equation of x of t. What is the equation of x of t? From 1 to 3. We were interested in the equation from 1 to 3. So for 1 less than t less than 2, what is the equation? For 2 less than t less than 3, what is the equation? If you observe from 1 to 2, the slope is within 1 unit. It has decreased by 2 units. So slope is minus 2. And here the slope is minus 1 because within 1 unit it has decreased by only 1 unit. Use whatever basic you know to find the slope and the equation. So the equation here will be minus 2t. And what is that constant? That constant should be in such a manner that if you substitute 2, the answer should become 1. If you substitute 2 here, it is minus 4. Then constant, if the constant is 5, then only it will become 1. Okay, substitute one of the values, then you will understand what is that constant. Next, similarly here, the equation will be, since slope is minus 1, it is minus t plus some constant. And what is that constant? So if you substitute t equal to 3, this constant should be in such a manner that the total result should be 0, which means it should be 3. Right. So we can write the equations for other regions also, but we don't need because we are integrating only from 1 to 3. So let us substitute this. It is 4 pi into integration from 1 to 2. From 1 to 2, what is the equation? Minus 2t plus 5 whole square plus integration from 2 to 3 minus t plus 3 whole square dt. Okay, so this is equal to 4 pi into integration of this is minus 2t plus 5 whole cube divided by 3 into differentiation of this is minus 2 in the denominator, limits from 1 to 2, plus integration of this part is minus t plus 3 whole cube divided by 3 in differentiation of this part is minus 1, limits from 2 to 3. So if you substitute the values, so it is 2. If you substitute, it is minus 4 plus 5 is 1 whole cube is 1, minus, if you substitute 1 here, it is minus 2 plus 5, which is 3 cube is 27 divided by 3 into minus 2. Fine. So plus, so if you substitute minus 3, it becomes 0. In the denominator it is minus 3. If you substitute 3 here, minus 3 plus 3 is 0. 0 minus. If you substitute 2, it is minus 2 plus 3 is 1. 1 whole cube is 1. So minus minus cancel. So this is equal to 4 pi into, so what is this? This is minus 26 divided by 3 into minus 2. So minus 26 divided by 2, minus minus will get cancelled. It will be 13 divided by 3 plus 1 by 3, which is equal to 4 pi into 14 by 3, which is equal to 56 pi, 14 4s are 56 pi by 3. So we can use the calculator to calculate what is the value of pi. So it is 56 into 3.14 divided by 3. So the answer will be approximately 58, 59, something like that. You can use the calculator to calculate it. So let me do it. One second, let me do it. Let me tell you the answer. Right, approximately 58.6, 58.6 or 58.7, something around that. So that's the answer. Right. So let us do the last one, last question. So transfer function is given, and they're asking us the value of alpha with mod alpha greater than 1 for which the magnitude response of the system is constant over all frequencies. You have to understand this. Magnitude response is constant over all frequencies. The meaning of it is magnitude response is constant for all frequencies means they're talking about all pass filter. Indirectly, they are telling you that the filter that they're talking about is all pass filter. And for an all pass filter, if A is a pole, then 1 by A star will be a 0. Okay, because pole zeros will exist in conjugate reciprocal locations. So, or let me give you the basic also here. So if this is unit circle, if there is a 0 at a particular location, if there is a pole at a particular location, the 0 will be here in this location. Okay, and if there is a pole at this location, then there is a 0 in this location. If this is A, this will be 1 by A star, and if this is B, this will be 1 by B star. Always, if they give you pole, you can find the 0. If they give you 0, you can find the pole. So pole and 0 exist in conjugate. Pole and 0 exist in conjugate reciprocal locations. So fine. So here, pole. What is the pole here? A. Let's say A is the pole. A equal to minus 0.5. So what is the 0 here? Alpha is the 0 here. What they have given. Alpha equal to 1 by A star. So it is 1 by minus 0.5 star. If you apply also, it is again minus 0.5 only, which is equal to minus into the numerator. 1 by 0.5 is 2. So alpha equal to minus 2. Minus 2 is the answer. So that's it, guys. So from signals and systems. So really good questions. The level of difficulty is not very tough. That's a medium, moderate, you can say. Right. So I'm teaching on Unacademy Plus. I teach signals and systems and communication systems. So if you're interested to subscribe for the complete courses that we teach on Unacademy, you can subscribe for Unacademy Plus. So right now I'm teaching analog communication course. Right now I'm teaching analog communication course on Unacademy Plus. So it has started on February 8th. So and one more course is there, Excel Gate 2021, which is taught by the most expert faculty in the country. So BS sir, Suresh sir, Trinath sir of MEDICI, B. Reddy sir of ACE Academy, myself Dinesh. I'm also an ex-faculty of MEDICI. I'm an IITian, and I am a GATE 2 times ranker in GATE exams. So everybody is an expert in whatever subjects they teach. So if you want to target GATE 2021, if you're really serious about it, you can come and join Unacademy Plus. You can take subscription, and we can help you with each and every subject. We can help you with doubt clarification. We can help you with the test series also. So if you are interested to take subscription, you can use my code Dinesh Gutha whenever you are taking subscription. So this is my promotional code or referral code, you can say. You can use this code when you are making the payment for 10% discount. Right. So that's it, guys, from my side. You can follow me on Unacademy page for updates on my classes. Thank you so much. I hope this class will be useful for you. Thank you.